Okay, now that you know what the Pythagorean theorem is, a squared plus b squared equals c squared, and you know how to use it and apply it, it only works on right triangles, don't forget, right triangles. We're going to do some application now and see if we can find some perimeters and areas of figures. So let's do perimeter first. Remember, perimeter is the total distance around the outside of a figure. It's the sum of all the side lengths. Add up all the side lengths, you've got perimeter. Well, if I look at this parallelogram, there's no numbers at all. But you can probably see some faint grid lines back there. And the grid lines are what you're going to use to figure out how big these pieces are. So like this straight line right here, up and down, this vertical line, is 1, 2, 3, 4 units long. And this is a parallelogram. This is also 4 units long on this side. The problem is that's only half of the perimeter, or 2 pieces of the perimeter. I need these pieces, but these are diagonal. And diagonal pieces I can't count using these grid lines. Don't try to estimate, oh, it's about 3, 4, 5.5. No, we don't do that. We calculate exact. We calculate exact using the Pythagorean theorem. So to use a Pythagorean theorem, we need a right triangle. Well, there's no right triangles here, but I can make one. So I'm going to draw a line inside of this figure to create a right triangle. There it is. And now I can see how long that line is. And I can use that and this piece here, which is not 4 now, because 4 is the whole length. So this piece is less than 4. I can use these two as legs to calculate this hypotenuse. And then this will be the same. And now I've got a perimeter. Same thing over here. This piece over here, well, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 units long all the way across the bottom. But I don't have any measurements for these two slanted sides. But I need to make a right triangle. I need to create a right angle. So I'm going to draw a line straight down through the middle here. And if I draw that line straight down through the middle, now I have a right angle. And now I have a right triangle. On each side, there are identical right triangles. Doesn't this look like those isosceles triangles from yesterday? So now I can figure out how big this line I drew was, how big this is, which is only half of that bottom because it splits it right in half, it bisects it. Use that to calculate the length of this side with the Pythagorean theorem. This side and this side are equal, and now I can find a perimeter. I'm going to do one more, but this one I'll actually do. This one's a trapezoid. The trapezoid's not too bad. It's giving me 3 measurements here. Just change my thickness here. It's giving me 3 measurements that are straight lines. I can count all of them. So like this one is 1, 2, 3, 4, 5, 6, 7, 8. This one is 8 units long. And this one is 1, 2, 3, 4, 5, 6, 7, 8. Also 8 units long. This guy down here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 units long. Notice, by the way, I'm counting the lines. I'm not counting how many boxes it is. I don't count the box. I count each grid line as 1 unit, just like you would on a graph, on a coordinate plane. But now I need this slanted side. And to get that slanted side, I need to create a right triangle. So I'm going to create that right triangle right down here through the middle. There you go. There's my right triangle. And now how big are these lines? Well, if this line out here is 8, then this line I just drew is also 8. And this isn't 14, the whole bottom's 14, but this is 1, 2, 3, 4, 5, 6. This is 6 units long. And now I've got myself a leg, and I have to find the hypotenuse. So if I use that Pythagorean theorem, a squared plus b squared is equal to c squared. The Pythagorean theorem says that 8 and 6 are both legs, and C is the hypotenuse. So 8 squared plus 6 squared is equal to the unknown C squared. And 8 squared is 64, 6 squared is 36. Add them together and get 100 is equal to C squared. And my final step in solving this has always been to take the square root of both sides. That eliminates the square. And now 10 is equal to C. So that means that this side out here, I'm going to make that blue because that's on the outside. This side out here is 10. And now, if I want to find the perimeter, this 8 and this 6 have nothing to do with the perimeter. It's 8's on the inside, and 6 is already part of this 14. That's why I made a different color. So the perimeter is just the 8, the 14, and the 10. So 8 and 8 is 16, plus 14 is 30, plus 10 makes a grand total of 40 units of perimeter. That's how I find perimeter of these figures. Now let's take a look at area. Area, remember, different shapes have different formulas. I gave you a bunch of them here that you're going to need. Triangle, area is equal to 1/2 times base times height. Or you could do base times height divided by 2 if you prefer. Parallelogram is just base times height, but that height has to be a perpendicular height. It can't be a slanted height. It has to be perpendicular to the base, making that right angle, which then in effect might make a right triangle. And trapezoid is 1/2 times the height times the sum of the two bases, base number 1 and base number 2. These are two parallel sides, these bases. You don't have to use this formula if you don't want to. You could take the trapezoid and break it into a triangle and a rectangle and then find the area of each of them and then add those together if you want. I'll show you both ways. So what I'm going to do with the trapezoid. Let's take a look at a few figures first. Triangle here. Well, if I need area, I need a base and a height. Well, I have a base of 12. Look at these two sides are equal. That means this triangle is isosceles. If I cut this triangle right down that middle, there you go. I just made myself a right angle. I made myself a right triangle here. That line I drew is the height. That'll end up being one of the legs. I'm going to ignore this half of the triangle and just focus on this right triangle and use whatever this leg is. It's half of that. This hypotenuse, and use that to find the height here. And then use the height and the base in my formula. This number will mean nothing when I'm calculating the area. I'm just using that to find the height. Same thing here. This is just the triangle itself. I need a base and a height. I have a base. I don't have a height, but I have a hypotenuse that's going to help me calculate that height. Once I get that height, I use that height and that base. This number is not part of my triangle formula to find area. It's just used to calculate the height. Here's a parallelogram broken up into two pieces. Well, if I look at this piece, this is not quite a triangle. Take a look at that. Not quite a triangle. So this piece is not what I'm going to use to find this height. I'm going to use this upside down triangle to find the height. And I see that that has a side of 8, a hypotenuse of 17. And I'll use that to calculate this other leg. And that leg, and then this base will be used to find the area, base, and height of the trapezoid, or the parallelogram. This 8 is not the whole thing. So technically, since this is 9, this is 8, this is 1. You don't need that, just something to think about. Here's what I'm going to calculate. The area of this trapezoid. Well, I see this is 4. That means this is also 4. I don't know how big this is, but I know it's the same as that. And that is part of this right triangle. So the first thing I'm going to do is I'm going to calculate this right triangle to figure out the height using Pythagorean theorem. So our good old formula, a squared plus b squared is equal to c squared. In this case, 5 is my hypotenuse. That's my C. I'm going to square it when I put it in right away. So that's a 25 equal to, this 4 is one of the legs. I'll call it B. If you watched the last video, they're interchangeable. It doesn't matter if you put it in for B or A. I squared it right away. I made it 16. A squared. Solve this for A. So subtract 16 from both sides. And A squared is equal to 9. And then take the square root of both sides. So A will be 3. So that means that this is 3. That means that this is 3. So now I need to calculate the area of this trapezoid. I'm going to do it two ways. I'll use the formal formula first. The formula for a trapezoid says 1/2 times height. Well, the height of this trapezoid, straight up and down, is 3, times the bases added together. The bases are two parallel sides, in this case top and bottom. Top is 4, bottom is 4 and 4, that makes 8. So 4 plus 8. All right, do it in parentheses first. 4 plus 8 is 12. So it's 1/2 times 3 times 12. And once I get to here, it's 1/2 times 3 times 12. I can multiply in any order, commutative property. I'm not going to do 1/2 of 3 because that's a decimal. I'm going to do 1/2 of 12. 1/2 of 12 is 6. 6 times 3 gives me a final area of 18. That's one way to do it. If you don't like the trapezoid formula, you could do it as two separate pieces. I could find the rectangle here area and the triangle here area, add them together. So if I do the rectangle, just length times width, 3 times 4, the rectangle has an area of 12. And this triangle is 1/2 base times height. This 5 means nothing in any of these formulas. The 5 was just used to calculate the height using the Pythagorean theorem. So it's 1/2 times base 4 times height 3. 1/2 times 4 times 3. 1/2 of 4 is 2. 2 times 3 is 6. And those two pieces are being added together to get the grand total area. 12 plus 6, still 18. Checko. That's how we find perimeter and area, but you have to use a Pythagorean theorem to calculate at least one of the pieces before you can actually find it. Good luck.